let us understand this concept using a simple example. Suppose you have a bottle of carbonated beverages. Initially, the cold drink tastes perfectly fresh. However, when you receive the bottle and consume it 3 or 4 days later, what will you gonna notice? You notice that there is a change in its taste. So, as we know that carbon dioxide gas is dissolved under the higher pressure in the soft drink bottle. At the moment when we open the bottle, the internal pressure drops abruptly. As the pressure decreases, the solubility of gas also decreases. As the solubility decreases, the carbon dioxide gas begins to escape from the bottle in the form of bubbles, and this precisely what creates the fizz we observe. So, what we understand from this concept is that as the pressure increases, the solubility of gas also increases. As the pressure decreases, the solubility of gas also decreases in the form of bubbles and the gas begins to escape. So, Henry's law is basically the relation between pressure and solubility. Now let's have a look to its definition. At a constant temperature, the amount of dissolved gas in a liquid is directly proportional to the partial pressure of that gas in equilibrium with the liquid. As we know that partial pressure of gas is directly proportional to the solubility. In concentration terms, solubility is written as the mole fraction. So it becomes partial pressure of gas is directly proportional to the zeta, where zeta is mole fraction. If we are going to resolve this sign, then it becomes partial pressure is equals to kH zeta, where kH is Henry's constant. If we define Henry's constant in the terms of solubility and pressure, then it is called the Henry's law of volatility constant. So there are some limitations of Henry's constant. Henry's law is only applicable when the molecules of the system are in the state of equilibrium. It doesn't applicable when gases are placed under extreme high pressure. It doesn't work when the gas and solution participate in chemical reactions with each other because it only applies on the physical dissolution. Now, let us examine a graph which comes from its corresponding formula, which is also in the terms of pressure and solubility. It gives a straight line graph where slope is equals to kh. Now let's have a look to its formula, which says that partial pressure is equals to kh zeta. If we rearrange this equation to isolate kh, it will give Henry's constant is inversely proportional of solubility. If we compare this graph with this graph, here we can see here that every gases in this graph reduce a separate. This graph is also in the terms of solubility and pressure. In this graph, every gas is following a different path. Oxygen traces a unique path, nitrogen traces a unique one, and helium traces yet another. So, why is this in this case? So, as we discuss that kH is inversely proportional of solubility. If we apply this relation here, then in helium, its kH value is nearly about 144 Pascal. Oxygen kH value is nearly about 34 Pascal, and the kH value of nitrogen is about 76.48 Pascal. So here, what we can see here that helium has maximum kH value, so its solubility will decrease, but here oxygen have minimum kH value, so its solubility will increase. This is what's shown in this graph. So now let's move. There is a relation which was always asked in the competitive and board exam. We know that there are two types of reaction on basis of processes. First is exothermic reaction. In exothermic, temperature is inversely proportional of solubility, whereas second is endothermic. In endothermic processes, the temperature is directly proportional of solubility. Now let's see the applications of Henry's law. First is to increase the solubility of carbon dioxide in soft drinks and soda water. The bottle is still under higher pressure. As we previously discussed about this example, that in the soft drink bottles, the carbon dioxide gas is placed under the higher pressure. Where if the pressure increases, the solubility of gas also increases. If pressure decreases, the solubility of gas also decreases, and the gas will begin to escape. Second, scuba divers must cope with high concentrations of dissolved nitrogen with breathing air at higher pressure underwater. To avoid this, air is diluted with helium. So why only helium gas is diluted in it? So as we know that pH value of helium is about 144 Pascal, and we know that KH is inversely proportional of solubility. From this relation, we can see here if the KH value is maximum, then solubility will decrease. It prevents the disease like bends, and which is also known as decompression sickness. Next application is at high altitudes. The partial pressure of oxygen is less than that at the ground level, where is low blood oxygen. Henry's law also applicable in the food packaging also. So remember, if pressure will increase, the solubility will increase. But if temperature increases, then the solubility will decrease. So from all these examples, what we understand that the higher the pressure, higher will be the solubility of gas in the liquid. If lower the pressure, lower will be the solubility of gas in the liquid, and the gas begins to escape. This is all about the Henry's concept. Hope you all understand. Thank you and have a great day.